are used in planning, analysis, and design stages of software development life cycle. Second, lowercase tools are used in implementation, testing, and maintenance. Third, integrated case tools are helpful in all the stages of software development life cycle, from requirement gathering to testing and documentation. Case tools can be grouped together if they have similar functionality, process activities, and capability of getting integrated with other tools. Diagram tools are used to represent system components, data, and control flow among various software components and system structure in a graphical form. For example, Flowchart Maker tool for creating state-of-the-art flowcharts. Process modeling is a method to create software process model, which is used to develop the software. Process modeling tools help the managers to choose a process model or modify it as per the requirement of software product. For example, EPF Composer. Project management tools are used for project planning, cost and effort estimation, project scheduling and resource planning. Managers have to strictly comply project execution with every mentioned step in software project management. Project management tools help in storing and sharing project information in real time throughout the organization. For example, Creative Pro Office, Track Project, Basecamp. Documentation in a software project starts prior to the software process, goes throughout all phases of software development life cycle and after the completion of the project. Documentation tools generate documents for technical users and end users. Technical users are mostly in-house professionals of the development team who refer to system manual, reference manual, training manual, installation manuals, etc. The end user documents describe the functioning and how-to of the system, such as user manual. For example, Doxygen, DR Explain, Adobe Robo help for documentation. Analysis tools help to gather requirements, automatically check for any inconsistency, inaccuracy in the diagrams, data redundancies or erroneous omissions. For example, Accept 360, Acompa, Case Complete for requirement analysis, Visible Analyst for total analysis. Design tools help software designers to design the block structure of the software, which may further be broken down in smaller modules using refinement techniques. These tools provides detailing of each module and interconnections among modules. For example, animated software design. For example, an instance of software is released under one version. Configuration management tools deal with the following three management components: version and revision management, baseline configuration management, change control management. Case tools help in this by automatic tracking, version management and release management. For example, Fossil, Git, AccuRev. Change control tools are considered as a part of configuration management tools. They deal with changes made to the software after its baseline is fixed or when the software is first released. Case tools automate change tracking, file management, code management and more. It also helps in enforcing change policy of the organization. Programming tools consist of programming environments like integrated development environment, inbuilt modules library and simulation tools. These tools provide comprehensive aid in building software product and include features for simulation and testing. For example, Scope to search code in C, Eclipse. Software prototype is simulated version of the intended software product. Prototype provides initial look and feel of the product and simulates few aspects of actual product. Prototyping case tools essentially come with graphical libraries. They can create hardware-independent user interfaces and design. These tools help us to build rapid prototypes based on existing information. In addition, they provide simulation of software prototype. For example, Serena Prototype Composer, Mockup Builder. Web development tools assist in designing web pages with all allied elements like forms, text, script, graphic and so on. Web tools also provide live preview of what is being developed and how will it look after completion. For example, Font Elo, Adobe Edge Inspect, Foundation 3, brackets. Quality assurance in a software organization is monitoring the engineering process and methods adopted to develop the software product in order to ensure conformance of quality as per organization standards. QA tools consist of configuration and change control tools and software testing tools. For example, SOAP Test, AppSwatch, JMeter. Software maintenance includes modifications in the software product after it is delivered. Automatic logging and error reporting techniques, automatic error ticket generation and root cause analysis are few case tools, which help software organization in maintenance phase of software development life cycle. For example, Bugzilla for defect tracking, HP Quality Center. Case tools provide automation and reduce the time to complete many tasks, especially those involving diagramming and associated specifications. Estimates of improvements in productivity can be upwards of 200%. Case tools can provide ongoing debugging and error checking, which is very vital for early defect removal, which actually played a major role in shaping modern software. The importance of early defect removal is very important. Less effort and time are consumed if corrections are made at an early stage, such as the design stage. As the system grows larger, it becomes difficult to modify. Error identification becomes harder. In some cases, restraining could be involved and that could incur cost in terms of time and effort. Managing and communicating problems among large teams can be difficult to manage, time-consuming, and costly. As a result of better design, better analysis, and automatic code generation, automatic testing and debugging, overall systems quality improves. Also, there is better documentation. Thus, the net effort and cost involved with maintenance is reduced. More resources can be devoted to new systems development. CASE provides re-engineering tools which can be very important because they make this process more efficient, less time-consuming, and less expensive by discovering older parts of the system which can be reused. By using CASE tools, vast amounts of documentation are produced along the way. Most tools have revisions for comments and notes on systems development and maintenance. With the increased movement towards object-oriented technology and client-server bases, programming can also be done by people who don't have a complete programming background. It would be important to understand the logic of the program and possess the ability to analyze the organization of the program and all the intricate details involved in generating good software. By using the lowercase tools, it could be possible to develop a software from the initial design and analysis phase. CASE tools can be used to allow for greater user participation, which can lead to better acceptance of the new system. This can reduce the initial learning curve. It's important to make an appropriate selection of tool mix to get a cost advantage. CASE integration and data integration across all platforms is also very important. The ability to share the results of work done on one CASE tool with another CASE tool is perhaps the most important type of CASE integration. In most cases, programmer productivity may fall in the initial phase of implementation, because users need time to learn the technology. In fact, a CASE consulting industry has evolved to support uses of CASE tools. The consultants offer training and on-site services that can be crucial to accelerating the learning curve and to the development and use of the tools. CASE is not cheap. In fact, most firms engaged in software development on a small scale do not invest in CASE tools because they think that the benefits of CASE are justifiable only in the development of large systems. The cost of outfitting every systems developer with a preferred CASE toolkit can be quite high. Hardware and systems, software, training, and consulting are all factors in the total cost equation. Potential CASE tool costs include the following: initial training and education, evaluation costs, maintenance of the model over time, upgrade costs of the tool, ongoing usage and maintenance fees, Time lost waiting for the tool to do its job. Time lost overusing the tool. Migration costs to port models to another tool. Increased effort to synchronize models with other artifacts, such as source code. CASE tools often promote syntax over communication between developers. Generated code often too simplistic or cluttered with extraneous information required by the tool. Poor user interfaces often hamper the modeling effort. Inadequate integration with other tools reduces productivity and/or requires integration work. Complex tools often prevent the inclusion of non-developers in your modeling efforts.